First, welcome. I hope you enjoyed the conference so far. My name is Marius Bogovic. I'm working for JBoss by Red Hat. I'm a Spring enthusiast, I could say, since 2005, which might strike you as interesting because it's actually a talk about migrating from Spring to Java EE. I'm the lead for a project called Snowdrop, which provides a Spring integration utilities for JBoss AS Server. So we try to get some deeper integration within JBoss. In time, I've started kind of dabbling more into Java EE, working a little bit on Welt, the reference implementation for JSR 299 for CDI. I'm contributing to the CDI 1.1 expert group. I'm working on another project called JDF, JBoss Developer Framework, which provides a set of tutorials and basically resources for Java EE developers to understand how to build better Java EE applications. So my experience has been basically in both sides on both sides of the fence, right? And what I thought about doing today is basically trying to give some sort of a practical overview of what tools you can use if you have a Spring application and would like to do more Java EE, right? Because we have something like that. So essentially, this is the assumption about the audience, which is very presumptuous, I would say, because I don't know any of you. How many of you fit actually this profile? How many of you are using Spring? Okay, check. How many of you would say that they understand concepts like dependency injection, cross-cutting concerns, declarative transactions, so on? Okay, you don't want. Sorry about that. And how many are interested in Java EE and learning about Java EE? Kind of cool. So we're all in the right spot. What I discovered when people try to use Java EE, so everything is great when you start learning about the differences. Everything is great when you start learning about the tutorials. Everyone's showing you how to start from scratch, and so on and so forth. But then what I found always hard is, for example, when people move to, like, from a Spring plus Tomcat environment and start moving into a more Java EE aware application server, there's also one way of using Java EE, right? And start asking questions, how do I set up things easily? How do I configure my application to take advantage of services? How do I write tests, right? How do I migrate my code, my existing code? What do I do with the existing code? Because greenfield applications are rare. And to say, I like saying that a lot of times production environments are more promiscuous than tutorials will make you believe. You have different types of code, different types of applications, mix-ups, and so on. So you have to juggle with that very often. And tools and utilities can take you a great way to actually solve the problems that appear there. So what I'm going to show today is some tools and technologies that can ease your transition into Java EE. Learn Java EE, use Java EE, understand how Java EE operates, right? So we're going to talk about Forge, and actually we're going to talk about not only Forge. How many of you have seen Forge demo? How many of you know that Forge has a Spring plugin? They can help you set up, okay. They can help you set up a Spring project to use Java EE services. How many of you have used Arquillian? You should. It's a very good product. It's a very good way of testing. Again, I'm going to show you how to use it for your Spring applications. It's another step of the transition. So I'm really envisioning this as a gradual process, becoming more familiar with Java EE services, understanding how to test in container, and then moving towards Java EE completely, if you want to do so. So the final step would be integrating Java EE and Spring, especially CDI and Spring, using utilities like the Theme3 Spring module, which we have right now, And how many of you have heard of a project called Delta Spike? Apache Delta Spike. That's pretty good. So Apache Delta Spike is basically a set of utilities that provide extensions to CDI for different tasks. So they can be core utilities or, let's say, something more functional utilities, like better integration with JSF or Spring integration or CDI query, for example. So we're going to take a look at that. And what I want to do is really demo all these technologies. So just to understand where I'm coming from in this discussion, I just want to clarify to talk a little bit about the role of Java EE services in Spring applications. Now, how many of you are using Spring and JPA? How many are using local entity manager factory bean? Or how many of you are acquiring from Jindy, for example? It is a server-side deploy. Quite a few. So my take on that is basically kind of Spring team's take in that the Spring is focused around three things: dependency injection, AOP, and portal service abstractions. And the first two are actually what forms the programming model. So that's platform independent, that's business concept, that's oblivious of infrastructure, and you actually spend 99% of your development time here. You don't worry too much about where your JPA entity manager is coming from or what's your transaction manager. You set it up once and forget about it. You start writing your controllers, your DAOs, and some other stuff. But what really happens under the scenes is that your application delegates to services. And so Spring has solved this through the concept of portable service abstractions like things like the platform transaction manager or the local entity manager factory bean, whose role is basically saying, well, if you're not running in an application server, you don't have to worry about the fact that these services are not available. You can supplant them by providing our own implementations, right? The thing is, we don't spend too much time in this, but this is where your application actually runs. So you may want to consider, let's say, the merits of using those services in your running application. So I'm really looking at a model where, at least as a first step in approaching Java EE, you would look at combining the programming model with portable service abstraction implementations, right? And there are advantages to this. One thing is, for example, using managed data sources. It seems a minor thing. Rather than using the basic data source, how many of you are using a Jindy provided data source, for example? Okay, I don't have anything to tell you then. For the ones that are not, though, there are benefits in using, in using an application, a data source at the application server level. They do not come from the manageability of the data source. For example, I'm going to provide an example from my own turf. A managed data source can be managed on JBoss using a command line interface. So you can write scripts to actually manipulate it. It doesn't matter too much for development, but it matters a lot for operations. Another example is using Managed JPA as opposed to bootstrapping your own entity manager factory within your project. You don't care too much about it because at the end of the day, in your user DAO, you're going to get an entity manager injected. What you gain by using this is that if the application server is really good, it can do optimizations for you. Like we do, for example, we use a pre-annotation scanning process to speed up the deployment of persistence units. It's an example of something that the server does. what you get through a service, which is not apparent in the when you think only of the programming model. Or you can use JTA for transactions. How many of you are using JTA transactions? Quite good. We advocate using JTA transactions because, for one thing, they integrate with their requirement. For example, if you use the server-side deployed persistence context, but it's not for that only. It's basically that very often when you combine Spring with other models, you have the issue that you have a transaction, you have local transactions created by some components, you have other transactions created by other components, and so on and so forth. And JTA actually allows you to basically propagate the transaction across different component models easily and don't think about it in a very transparent fashion. And again, if you worry about the performance in JTA, just remember that most transaction services do not use two-phase commit for for single resources. Most of them downgrade to a one-phase commit, which is a really small difference compared to local transactions. But you get a lot in terms of ease of integration. And there are some other things, like how many of you are using messaging in applications? Now, if you use messaging, you have different strategies for configuring. How many of you are using message listener container? Right. Now, in Spring, you can either use the default one, or you can let the application server messaging system actually take care of passing messages to your listeners. Again, there are advantages in doing this. An application server normally optimizes transaction integration, message delivery, consumer caching, session caching, and so on and so forth. It doesn't appear, at the programming model, this is not evident. When you actually run, you get benefits. And the first question here is, yeah, okay, fine. I'm going to start using Java e-services to back Spring's programming model. One question that, for example, shows up from our users is, okay, I'm going to do that. How do I do it? How do I start up easily? And how do I start an application easily with Spring and actually set it up to use this? A container managed entity manager or or JTA, right? Or you can copy and paste code, but we have a better solution for this. And I'd like to introduce Forge. Now, Forge is a rapid development tool that we lead at JBoss, but in fact it's a community project. So it has a lot of contributors from the community, extending the core, but especially creating extending the ecosystem of plugins. It's very easy to. What it does is basically helping you start up a project, set up the infrastructure, create components, create entities, scaffold, and so on. So let me just give you a quick example. Oh, this is the Forge console that's available in the JBoss Developer Studio or JBoss Tools. I prefer using that. It's Command 4 as a shortcut. But if you install JBoss Tools, or if you can open it from here, so you show view, it's a view, and you basically say Forge. That's the Forge console. So I can start a new project, right? I create a new project. It's very easy. Let me just... This basically just creates me a basic structure. Nothing in it. I didn't tell it what kind of a project I want to create. I can add persistence to it. It is, yeah. So the question was whether Forge uses, yeah, Forge generates Maven-based projects. We find it easier to, they lend themselves easier to being manipulated in this way. How many of you are using Maven? Okay, that's a lot. It might not be that bad. And, for example, there is an idea right now that it could also generate Gradle-based projects as a plugin, as an option, and as an extension. But Maven is probably the easiest to integrate with because there are good libraries for processing XML and for processing the POMs and stuff like that. So I can go and very easily create my persistence layer. I can go and create for example, an entity. No, it doesn't. The question was whether it does my baddest. It doesn't, although there was a proposal for a plugin that can do that. So right now it's very, in some sense, Forge is right now very somehow Java-centric, right? But again, you'll see that we can actually add a very, I can add Spring on top of it. So okay, this generates me an entity, right? We all know how to write an entity. It's not that spectacular. What I'd like to do next is kind of set up my project so that it uses the things that I've been talking about regarding Spring configurations, like GIND, an entity manager required from GIND, JTA transactions, and so on and so forth. So first, I'm going to create the field so that this entity has actually a use. Right? So I created it like this. And right now I can go on in two directions. I can generate a scaffold with JSF and all the other stuff. I can create a number of RESTful endpoints with JXRS, right? Or I can add Spring. So here's what happens. Yes. The problem is that I disabled the shortcut. It's Eclipse not being very cooperative. So you got me, I'm an IntelliJ user. The problem is it doesn't affect the console, it just affects the code. Okay. It's good then. Thank you. As I said, what's wrong with these IntelliJ users? All right, so unfortunately I don't have a Forge plugin for IntelliJ, so I cannot demonstrate that. And this actually works out very nice because it shows you the code and as it's being generated. All right, so I set up Spring. And here's what happened. It added Spring to my application. It added an application context. But more importantly, just refresh. Yeah. Okay, so it's this is what happens when you don't sacrifice a rubber chicken to the demo gods. I'm sorry? Yeah, I should do that next time, because obviously it's... Well, yeah, I mean, it says that it's located there and probably has generated, but Eclipse refuses to reload the project, so... Yeah, I think this is a bug. No, it is a bug here. Spring. No, it's okay. Okay, this is not what I hope to show you. Fortunately, it created something, and right now it just... Eclipse refused to refresh itself, and right now it's mangled. So I have to recreate it again. You might wonder why I'm suggesting you to do this. It's because, in general, it works. So I did it in only in one command. Basically, you can do it in two. This one didn't work that well. Basically, what I did is I was telling the project that this is a web project using Spring. So what it did is basically it has changed the type of the project in the POM to war. But more importantly, it has generated context definitions. So this is basically the entity manager factory. and the JTA transaction manager, right? And everything else is basically a Spring B. So I can go and say scaffold. And this basically generates the rest of the project. Right? So now, this is my running application. It got started easily. The infrastructure is there, the rest of the programming. I say the interesting part is not the scaffold itself. The interesting part is generating the configuration easily and get it set up, right? I think that's probably one important step when migrating, like when migrating to Java EE, kind of starting of thinking of the application server as a provider of services that can be used. Okay. Fine. We are using the Java infrastructure now. That's very cool. What happens to the tests? The biggest problem when you're actually starting relying on server-provided services is that you typically don't have them in a unit test. And this is one thing where, which Spring test, for example, was pretty good at. That's not a problem. We have the means for actually testing applications that run in container. So here I'd like to introduce Arquillian, for the ones of you who haven't encountered it.
So before you move on, I might miss it, but could you recap why would I want to move the Spring app to JPA?
Okay, we can talk about it at the end. I really didn't want to. I didn't want to enter this discussion necessarily. I'm taking that as a given for the discussion. Why do I want to use? I'm sorry? Yeah, we can have a debate at the end, and I'll explain my motives, why I'm interested in it. I think there are very valid reasons right now to use Java EE as a platform. And the Java EE as a platform has attained a maturity and ease of use that don't justify some of the things that you would have gotten, let's say, 7 or 8 years ago if you started using Spring. That's in a nutshell. So moving forward, on the other hand, the component model is going to become more pervasive. So stuff like CDI is going to be used much and more across. And I think you would gain a lot by adopting this, by adopting this right now. That's one of the reasons why I became involved in the work, while recognizing that Spring is a powerful framework, is a useful framework, is a popular framework, and I personally like it. I personally, at the same time, I'm working on the Java EE side because I think it has a very valid, very compelling development model that makes it easier, maybe even easier at this point, to use if you use a Java EE stack. That's my personal opinion. I mean, that's how I see things. You may not see things this way, but I really wanted to address. I don't really want to address this part, and that may be something that may not be well received. I think I really wanted to deal with the practicalities of the move rather than the, let's say, the ideological reasons for why I do that. But I'm personally committed, in saying that you can create powerful, very simple, and I'm saying simple not in the sense that they lack sophistication, but they actually are easy to develop in Java EE, and you would gain a lot for adopting it. That's my opinion. All right. Yes.
Why would I keep using Spring after using Java?
Unfortunately, because in a lot of cases, if you're fortunate enough to gain approval for a full migration of your application, it's fine. You can migrate your applications fully. But a lot of times, applications don't migrate that easily. You don't get to spend time on code that's existing and works. If you have a full application rewrite, then by all means, go for Java EE. We discovered that with a lot of our users, it's not always the case. They would like to migrate gradually and start developing in Java EE while keeping some of the older code, just because they cannot really, they cannot be in two places. They cannot do the migration and implement new features. And they're paid for implementing new features. So they adopt Java EE while having the opportunity of actually integrating. It's a practical problem. It happens a lot of times.
I understand it's a practical problem because we have projects and everything, but then if you are you going to show that how you can move transactions? Because otherwise it's not saving time. Now you're making two environments and making things more complex. That becomes harder for people to maintain, from my experience.
I can show you how you can use code side by side, and I could show you that the code actually that you have side by side, that the CDI code is actually not that different. So the beans themselves are not that different. I would say that if you're interested, like Bert Ertmann and Paul Bacher have done a very good talk on showing exactly the migration process, step by step. I really didn't want to get into the, let's say, in repeating what they said. However, they didn't talk about the tools themselves. And I really want to demo these tools and these technologies, go into more depth in what can you use. Now, if you want to test applications in container, you have tools like Arquillian that actually provide you a very good way, like bridge basically the gap that is between Java EE code and testing. So basically, if you migrate towards, like if you start using Java EE services within your Spring applications, you can use actually the same infrastructure as Arquillian and actually start tuning your applications in your tests in container. So let me just show you a quick example of such an Arquillian test. So this is a unit test. Let me just increase the font. This is an example of a test written with Arquillian. You can run it in any application, in any application server you want, right? It's not different, like it's not very different than a normal JUnit test. What's special about it is that you get to create a test archive. You put the portion of your application that you want to test. You get to put your configurations in it, and you start the test. So. So you see the test here. Actually, starting the server, doing the deployments, and essentially running the test. Why insist on doing this? Because this is exactly how you test your Java E code as well. It's the same process, the same thinking. You have differences in what you're actually testing against. But basically, you can imagine that instead of an auto-wired bean, you would have here an injected EJB. And it's quite the same. Yes?
You're doing the micro deployment to the JBoss app server. What is required to be set up on the app server in place in order to run Spring applications? Do you have to set up your dependencies and run all the rest of that kind of stuff?
No. It's a good question. It's actually the test itself is packaging the. So the question was, what do I need to set up on the server side to get? Actually, it does package the Spring artifacts. It packages the Spring dependencies and it resolves them through Maven. Yes, I mean normally you would create your. What you could do is use the modularity features and install Spring as a shared library, and that would probably reduce the size of your archive. So that would be a good idea anyway. But we kind of try not to assume that you did that. That's some sort of a detail. I mean, it's not really a matter of you don't have to put them this way. Yes, yes. So basically, after you migrate the code, for example, you would have to here just CDI beans, no dependencies because you have everything in your application server, and it's the test. The cool part about all that is the test is virtually it looks virtually the same. If the beans are if the beans have injection capabilities. I mean, if you use something like, if you really use something like @inject, you can take a look at the bean and not know what it is, whether it's a Spring bean or a Java E bean.
But if this test runs on your build server, for example, the build server would
You can do it in multiple ways. So this is running it in a managed container. You can have a central instance. You can set it up, for example, for our build tests, like when you do integration testing with stuff like this. We basically grab the server through Maven, which is a Maven artifact, put it in the target directory and run it from the target directory. So you basically have almost no external dependency. And normally if it's cached, like if the artifact is cached locally, you have no problem with that. Yes?
So this test happens to start debug?
It can start other servers. So you can start Glassfish. Yes, it starts GBoss. Yes. Yes, you can see the console. Yes, so everything happens in about 2 seconds.
So if I have thousands of tests that I end up starting debug?
No. Depends on how you write the tests. If you have them, like if you want, you can do that. But normally you would start it once, run the test battery. So basically every test is a deployment.
And my application,
Yes.
it takes 2 minutes to start debug, and it takes 3 minutes to start my application.
Now, what version of JBoss are you using first? What version of JBoss are you using? Okay. Okay. First, yes. Let me just answer the question. The server is started once for the test battery. Each deployment is separate. Each test class creates a separate deployment. So you basically have the server started once. You can put multiple methods in the test class. So you can group as many test methods as you want per deployment. So you can reduce the number of deployment of times, for example, the deployment takes place by simply grouping the test methods together, right? So you have options of actually reducing the overhead of starting the application server. Yes, but what you don't get is basically you don't get to touch the runtime in any shape or form. And we find that sometimes that's an issue because the tests do not reflect how the application actually behaves on the server.
What would be engineering then so that I have a test class basically probably was part of that because the server class, like still have all my test segregated test class?
You can set it up. You can set them up, but it's usually you can set them up that way too, I think. What you can also do is, for example, just deploying a running application server. Deploying a running application server, and don't give the overhead for that.
Is there any way to package like an embedded version of the container?
Yes. So it also supports running against. So you can run against the server, you can run against and locally, basically, just like Spring Test does. You have this option. But we prefer, like we see the real value of Arquillian deploying into a Java application server. Like this is where it actually shows the real value. So now, that's fine. So for the last part, I just wanted to talk a little bit and demo one integration between CDI and Spring, which would be again one of the problems that you have when you try to migrate the code very often. Basically, if you look at the two, right, it's very easy to learn Java EE. For example, if as I said, you understand injection, you understand the concept of a container, you understand the concept of a bean. It's pretty much the same. The idea is that you create object graphs based on a blueprint. You have the managed object, which is a bean. Both support standards like GSR 330 or which is at inject or GSR 250. So basically, if I write a class using at inject, like here, like for example here, I can't tell what kind of a bean is this. It's very easy to understand. That's my point. Of course, the differences are more about the relationship between Spring and Java EE. So Spring is basically something that lives on top of Java EE services. CDI is the native Java EE component model. It's tightly integrated by design. And it will become tighter as the Java EE specification moves forward. So we'll get more and more cases where components are injected by default. Right? Things like, I don't know, injecting a service into a JPA event and stuff like that. All of this happens by default. It's managed by the container. So the benefit is that your code actually becomes simpler and simpler. And as I said, defining beans is a very simple task. So basically, any class is essentially a managed bean and participates in the injection process. You can exclude some of them, or you can, like when you can't produce such class, like when you have classes that are coming from other libraries, you simply, like for third-party libraries, you can use a producer method to actually create new beans. And that creates a bean per se. Injecting a bean, for example, is very easy. You just use the add inject annotation. And again, it's really easy to move across if you understand how it works. If you look for concepts like more advanced concepts like interceptors, where you would write an aspect in Spring, CDI allows you to write very intuitively interceptors. So you basically can create an interceptor binding, a special annotation, and then apply it on a specific method, and then specify what is the interceptor that will actually be applied on that particular method. So it's very easy to create a DSL around your cross-cutting concerns. Again, another thing that CDI has is decorators. It's very easy to, if you have a class, for example, decorators require an interface, you can actually create a class that decorates this and basically add functionality to existing classes. So the development model is powerful. It's powerful enough that this, for example, is a complete business component. So, yes? Well, it's applied automatically. So what happens is that what I'm saying here is that any instance of service that is managed by the container will get this enhanced service around it, and essentially the method do something, for example, will actually execute and optionally delegate to the wrapped instance. If you want to think of the decorator, think more of interception based on interface, right? So you rather want to enhance the classes that satisfy a certain contract.
Yeah, I understand the decorator pattern, but when you write a decorator pattern, why do you need to really say and decorator?
So that because sorry. No, the annotation at decorator is basically to tell the framework to treat this as a decorator. It would otherwise it could be a normal bean. What happens is that wherever an instance of service is, like wherever I do inject service, whatever, I will get a decorated instance. I don't have to request an enhanced service. In fact, I cannot inject an enhanced service. You know, so for defining full-fledged business components, I can write, for example, very easily an EJB. So this is a dependent service, it's a simple POJO, doesn't do too much, right? An event repository. And then I can inject it into an EJB. I mean, very often we use EJBs for, like, EJB is basically, an EJB is a component that you want to use for setting up things like transactional boundaries, perhaps security, and so on. And moving on to, like, EJBs are essentially much less. One point to make here is that EJBs are much less verbose to implement than they used to be in previous versions, right? Up to Java, definitely less verbose than before EJB 3. Now, moving forward, the specification is actually even more permissive. So in Java E7, for example, you will see that transactional attributes can be applied to any kind of bean. So you have that option too, if the only thing that you want to have is transactions. The point is that that one of the advantages of moving to Java EE is exactly what I showed you. You can very easily create these components. And the programming model is very powerful. The question that remains is, okay, what do I do with my existing code? And there are various options, right? What I'm going to show you right now is one component that we have developed as part of the Seam Spring project. How many of you have used Seam in the past or have heard about it? Seam 2. Now, Seam 3 has been designed not necessarily as a successor to Seam, but more to provide a set of extensions to CDI. At some point, it became apparent that a lot of other groups, like the Apache project, created their own extensions. So rather than having everyone write their own extensions, which did virtually the same thing, or with minor differences, it's been deemed better to create a single project which pulls all of them together. And this is how the project Apache Delta Spike has come into existence. Basically pulling stuff from Seam 3, Apache Cody, CDI source, and other contributions from the community. And this is basically the future of this extension. This is the future of the extension that I'm going to talk about. But right now it exists in this form as part of the Seam 3 Spring module. What it allows you to do is do two things. Consume Spring beans as CDI beans, and vice versa. So how does it happen? It's basically, the problem that we are trying to solve is exposing, like creating application contexts and exposing Spring beans as CDI beans so that the injection process can take advantage of them. So what we do here in order to do that is really, we can install a Spring bean, Spring context as a CDI bean. And we can acquire this context either, for example, if it's bootstrapped from a context loader listener, or we can bootstrap this from the extension itself, right? And we'll look up for this file and we'll create the application context. Once the context has been bootstrapped, it becomes a source of beans. So I can go and say, well, I want to produce a bean, a user service bean, which is in fact the user service bean from the application context. In the future, like in future versions of the framework, we will try to automate this process a bit more so that the beans are imported automatically. one of the problems is that if the web context is bootstrapped if the web application context is bootstrapped by the context loader listener, so you want to keep part of your application still working, that happens after the CDI container has been initialized. So we don't have access during the initialization process. And CDI is very restrictive with respect to how, to the fact that dependencies have to be available. So basically, you can create this bean, and I can inject it into a session scoped bean, just like this. In reverse, I can do the same thing with Spring beans. So I can, if I'm developing, for example, a component, a specific component in CDI, and I just create it like this, I can simply reference it and use it within my Spring application. So let me show you a quick example. That's a good question. You will want to avoid that. You will want to avoid that. So basically what happens, unfortunately I don't have it, actually, but I can show it to you. It's actually a good question, and I will show it in the demo. Yes, so it's actually a bit worse than that. It's not only that you get a duplication in memory. The problem is that a CDI deployment will treat every bean, every class it founds, as a CDI bean. So if you have a bean produced, so let me just show this quickly. Well, I really want to show you the code here because it makes more sense. The demo itself, like running the application, it just proves that it works. But what I want to show, what I show you is this. So I have this user DAO created by my application, right? And then I have this greeter that is delegating to this invoker object. And the invoker object is in fact a CDI bean. Now what it does, the invoker object is also consuming the user DAO, which is in fact a Spring bean. This is a kind of contrived example. It's a controller delegating to a CDI bean, which is delegating to a Spring bean, just to demonstrate bidirectional injection. Now, the interesting part is this. Sorry. Look at this veto annotation, right? This is a CDI extension, so that's not part. This is going to become part of the CDI core specification, but it's basically using an extension that can prevent beans from being installed into CDI. I really don't want to have a CDI bean at this point, which is a user DAO implementation, because I don't have what to do. I don't have anything to do with it. When I migrate, at some point in the future, when this code is going to be migrated to CDI, I will remove both these annotations. I will remove it as a service so that it doesn't get installed into one context, and I will let CDI actually take its course. So basically what happens here is, you see the CDI greets join do, which happens because the invoker, the invoker here is basically processing the call. Right here. And then the invoker is delegating to this Spring bean for doing its job. That's the whole trick right now. But it takes a bit of work to get things set up. Let me just show you how this comes into place. Basically happens like this. First, I have a context producer which tells me what context should the extension use for grabbing Spring beans. Because this is a working Spring application, I didn't want to remove the context loaded listener altogether. Although, if I didn't need it anymore, if my MVC stuff was completely migrated, for example, I could have simply put here a configuration annotation and had Spring do that. Extracted from, like, had CDI do the bootstrapping itself. And actually there would be advantages for that, because CDI could actually do the auto-vectoring of beans, and my extension could do much more because it knows that these beans are under its control. And then the other option, the other thing is that I'm creating this producer here, which creates my user DAO bean and installs it into the, basically it is a producer field. It's following the resource producer field pattern, which basically what it does is you will see that nowhere in the application, for example, this is actually injected, this field. It's really done by the Spring extension, the actual instantiation of the object and population of the field. But once it's there, CDI will use the value in this field to actually do the injection wherever a bean requests it, like here. So, this is basically, once you reach this point, you can start thinking about really moving code from one side to the other. I wanted to show these tools because I really think that they are useful. Like, in general, we get a lot of questions about one or another of these facilities. Setting up infrastructure in Java E style, testing in container, migrating code, and basically using this migration. So, thanks a lot. If you have any questions, you're welcome. I'm here to answer your questions, but if not, then I hope you had a great conference. Thank you.